Hi everyone, welcome to lecture 1.2, linking learning to the course. So we're going to take the stuff we talked about in lecture 1.1, all the things about long-term potentiation and short-term memory and long-term memory and all that good stuff, and kind of be pretty explicit about how that relates to the course structure and how to succeed in this course. Now, before we get to that though, let's talk about that lecture question I posted at the end of the first lecture, where you are supposed to sequence the correct process of memory formation. Now, you have a few options here. You have perceiving a stimulus, long-term memory retrieval, and sensory memory. So, were you able to put them in the right order? If you said C, you did. So, good job if you said C. If you didn't say C, no big deal. Let's talk about it for a second. Okay, first off, usually what I do when I see a question, the first thing I do, with all questions in fact, is I completely ignore the possible answer choices at the bottom. Okay? I often find you spend a little too much time looking at that and being distracted, rather than looking at the important information such as, what is this question asking me? Speaking of which, you're going to want to identify the outcome the question is asking about. Now, we're pretty explicit here in general biology. We give you the outcomes ahead of time on the syllabus, right? So they're on the syllabus, and we talk about that pretty explicitly during workshops with the bias forms and whatnot. So it shouldn't be too hard, particularly since we also very explicitly write the questions to indicate what outcome we're going to be talking about. In this case, what is the outcome? Anyone know? If you said sequence the process of memory formation, then you'd be correct. Okay, now that I've correctly identified the outcome the question is asking about, in this case, the sequence of the process of memory formation, what I want to do is actually create an organizer, right? So if the question is the outcome, the answer is the organizer. So what kind of organizer do you think we're going to make for a sequence type question or outcome? We typically only make, let's say, tables or flowcharts. So what do you think? Right, a flowchart. So I have a little whiteboard here. You can use it either like a whiteboard like this or a piece of paper, and I'll quickly sketch out on my whiteboard. Let's see, I'm going to be doing you have a stimulus that triggers your stim memory or sensory memory, and then sensory memory gets encoded into your short-term memory, which you then encode information into your long-term memory. You also need to retrieve information from your long-term memory. Okay. And then that process of retrieval and encoding, that's LTP. You can also forget stuff, I suppose, right? So that's the thing. Forget. And then encode, retrieve. Alright, okay. So we can look at something like this, right? Hopefully it's, has better handwriting maybe, or is more legible. But I mean, for me, this makes sense, so that's alright. That's the important part. So then I have my organizer here. And then the next thing I want to try to do is you can actually go through and label the different steps in my flowchart with the Roman numerals you see on the screen. Right? So I have perceiving a stimulus. That's number 1. Easily done, no problem. I have long-term memory. Oh, that's all the way over here, number 2. Okay. I have retrieval. Well, retrieval could be... retrieval's at the end, right? So retrieval is just before long-term memory. So that's 1, 2, 3. It's over in here somewhere, right? And then I have sensory memory. Well, sensory memory is all the way back at the beginning. So it's 4, right? So now I have everything labeled. I have 1 is the stimulus that you receive at 4, the sensory memory, and then it goes to the long-term memory first, right? You have to enter the long-term memory at 2, and then you can retrieve it into the short-term memory. So it's 1, 4, 2, 3. So you got to retrieve from the long-term memory into the short-term memory. Now I just have to go through these answer choices and say, hey, okay, C, right? C follows this chain that I just drew out. 1, 4, 2, 3. There you go, 1, 4, 2, 3. And sure enough, that was the correct answer, right? Great, not so bad. Okay, so now eventually, I'm going to try to do this for the first couple lectures here, where we're going to have, one of these lecture questions in the beginning of the next lecture. I'm going to kind of break it down, tell you how I got to the answer, that kind of thing. Eventually, though, I'm going to stop doing that. I'm going to stop breaking it down, option by option or answer by answer or whatever. And it's going to be up to you to figure out why the answer is correct, right? I'll still tell you the answer, but I'm not going to tell you why it's correct. And any guesses as to why I would do this, as to why I would stop telling you exactly why the answer is the right answer? Is it because I'm a sadist and I enjoy seeing students flounder around? No, actually, I'm not. It's because I want you to come up with the answer on your own, because that's going to be lead to a much stronger understanding of the content than if I were to simply just tell you. All right. So anyway, let's move on to the lecture content for today. Lecture 1.2, linking learning to the course. Oh, hey, that just reminds me. Look down here. I have the BIOS form. I think I forgot to finish filling it out from last week. Yeah, talked about learning at the end here. No big deal. Or by last week, I mean last lecture. But let's then start this lecture segment's portion of the BIOS form. Okay. Now, all right. Back on track here. Let's get back to this content stuff. So we remember from lecture 1.1, this is the process of memory formation that we actually just went over in my terrible this thing, right? Well, what does this process of memory formation have anything to do with this, right? Remember, this is the structure and content of the course, which hopefully you recognize from the How to Succeed in General Biology lecture. Now, or video, I guess. It wasn't necessarily a lecture, though I guess it kind of was. Anyway, if you don't recognize this little diagram here, make sure you go back and watch that How to Succeed in General Biology video, like now. Anyway, okay, so to relate these two things together, we're going to take this sequence we have up here, this flowchart, and we're going to flip it a little bit and rotate it a little. Okay, great. There we go. So, right, so we still have our stimulus and sensory memory and short-term memory and long-term memory. So that's the learning process. Excellent. Now, your study process should actually look something like this, right? We have our lectures and notes, right? So you listening and watching lecture, that's a stimulus, right? You taking your notes and writing it down, that's encoding it into your sensory memory. Now, the planning, strategizing, and organizing, that would be like taking those notes and then reorganizing them into a BIOS form, or the P.E.P.P.E.R worksheet, for example, or maybe even drafting a couple of organizers. That's a great option as well. So that also has to do here with your short-term memory. Now, long-term memory involves practicing that content over and over again. So if you're trying to encode it from the short-term memory into your long-term memory, you're going to want to practice that stuff. And then you can also evaluate your ability at practicing that stuff. Okay, so that means if you're like trying to recreate an organizer that you made before, if you can't recreate it perfectly, well, that probably means you need to practice that a little more, need to refer to your notes a little more. Okay, so that's kind of how the process of studying should really look for you. So you go through your lecture notes, you go listen to the lecture, you write your notes, you organize and plan. Maybe you definitely use the bios form. Maybe use the P.E.P.P.E.R worksheet. I recommend it. Maybe use the P's of biology worksheet. You create some organizers, and then you start practicing those organizers and evaluating how well you're doing. Now, this is all stuff you do, right? Hopefully on your own, maybe some resources that we provide. Now, let's talk about workshop, right? This thing that you have to attend once a week starting the week of September 14th. So what does a workshop have to do with any of this stuff? Well, in workshop, you're going to be doing stuff like outlining the content, creating organizers, and then down here, there's a lot involved with getting information from your short-term memory into your long-term memory in terms of discussing the information with your peers, presenting the information. We don't quite do think, pair, shares anymore during workshop, but similar stuff. So don't worry about that one. But the moral of the story is that you're discussing the content with your peers, and you're also doing self-evaluations to see how well you're doing or you think you're doing. Okay. Now, how does this all facilitate learning, right? That's kind of the major goal here, is to facilitate your ability to learn this content. Now, in general biology, we try to utilize an active learning environment, which means that students are the ones actively engaging with the material by working on the concepts and discussing them in groups. This approach helps foster memory formation and long-term potentiation, unlike passive learning, where you aren't necessarily engaged with the material very much. Why? Why does this work better? Well, let's use some of those simple network models that we had talked about earlier in lecture 1.1 to illustrate the differences between a passive learning and active learning approach. So here's reading would be a very classic example of passive learning. You are not really connecting with the material in kind of diverse ways when you read, right? So you're just looking at the words and trying to relate them to the content. So that idea of spatial summation doesn't really happen. It's very difficult to do, right? It's very difficult to get spatial summation to occur. That then leads to long-term potentiation. Instead, you have to read the same things over and over and over and over again to foster temporal summation before you can really get it down. So it's not particularly efficient. Now, on the other hand, a more active approach like drawing organizers is a little bit better. So you're actually connecting what you're doing with your hands to the vocabulary and to the images that you're drawing. And the vocabulary, you're now attaching it to the images and so on, right? So because you have these more connections between the ideas and how you interact with the ideas and the topic itself, you have spatial summation. So you have a more efficient approach to fostering long-term potentiation and fostering learning. So that was passive is reading, active is creating lots of different interactions between concepts to kind of foster this learning process. Let's talk about workshop then, right? Now in workshop, you're going to go over the BIOS form, make sure everybody's on the same page with the summarized version of the notes, make sure everyone knows kind of the important parts that are being discussed, as well as the outcomes and how they relate to the organizers. In other words, make sure everyone knows what the exam questions are going to be and the most efficient way to answer those exam questions. So that's the first step here, going over the BIOS form. Then you're going to make the organizers themselves in small groups, usually about 3 or 4 people. So when you're working in groups, 3 or 4 people are typically the most efficient way to work. That's what we're going to be doing, helping come up with different ways to present the information, or making sure that everybody has the right vocab on their organizer, or making sure nobody's missing content, that kind of thing. Then you're going to discuss the organizers as a whole class. So everybody in your class is going to discuss, and this is great because maybe a different group has a totally different approach to those organizers than you did. Or maybe, it gives more people an opportunity to notice any errors or any missing content. Now, all of this is being moderated by a graduate student facilitator who's also could be considered your TA or teaching assistant, right? Now, the reason I'm being particular in calling them a facilitator is that their goal there is to facilitate your learning, right? So they're going to ask you leading questions. They're going to kind of point you in the right direction of where you can find the answer, or maybe even get your peers to answer for you or for the class, right? They're trying to get you guys to do as much of the kind of learning as possible. You can almost guarantee they're never going to provide you the answer. All right, so this last point really trips people up sometimes. They get really upset, like, why isn't my TA telling me what's right or what's wrong, and yada, yada, yada. Well, the point of that is that it's a much more efficient way of getting you guys to actually learn the content, is when you derive it on your own. So they'll help you by pointing you out how to derive the answer, but they won't give you the answer. So what does that have to do with our network diagram thing, right? Well, here you go. Doing the organizers with the team has you drawing out the images, filling it out with vocabulary, talking with your teammates, having them answer and describe how the organizer works, what makes a good organizer, what makes a bad organizer. It also has you using your hands to do it. Now, granted, right now in this particular format of online, you'll be maybe using your mouse or your keyboard, so it won't be quite as hands-on as it could be if you're using a marker or something like that, which I still recommend you do. But it'll still be very effective. As you can see, causing these very diverse sets of interactions between the content and how you learn the content. So in other words, Workshop is a very active process. It fosters that spatial summation that we talked about. It makes learning much easier by making diverse connections with the material in a lot of different ways. So this is really the ultimate goal of how we structure the course and the learning tools we've designed for you to utilize, right? Active learning to foster long-term potentiation, meaning, you can foster that through temporal summation and spatial summation. So we briefly introduced some of these learning tools in the introduction video, and then I went over it in detail during the learning resources video. Right, so these are the learning resources down here. We have the P's biology, the S.A.L.T, the P.E.P.P.E.R, review sessions, practice groups, and then even discussion forums. But let's go through these again. But now that we have an understanding of the memory and learning and how they fit together with that process. So let's look at the BIOS form. Now, remember, the BIOS forms are for telling you exactly what and how you need to practice. They're telling you the outcomes, or the exam questions, and the organizers, the answers, right? So how does this fit into that kind of a learning framework that we keep talking about? This diagram of concepts. Well, using that network model alone, they're clearly not necessarily the most efficient way to learn material, but that's not necessarily their role. They're really the foundation for building everything else by identifying what you need to know, the outcomes, and the tools you need to learn that content, the organizers. Yeah, speaking of which. So we've talked about organizers a little bit already, particularly in the How to Succeed in General Biology video, which you should watch if you haven't already. But why? What makes these so effective in terms of studying tools or learning tools? Well, they allow you to structure content in a way that makes sense to you, which basically means how to chunk this content together, how to find similarities between things, how to identify how things are related to each other. So, for example, here we have this table on the top right of your screen that is comparing and contrasting prokaryotes and eukaryotes. And we've chunked together some of the differences based on categories. So we have structure, we have their evolution, we have the size, we have what domains make up prokaryotes and eukaryotes, we have organelles, and then we have some examples of the two. So in this way, you've created chunks of information to relate between these two types of organisms. Great. So that's how you can use a table. Now, flowcharts are a little different, but similar. So the idea is you're now adding a sense of sequence or order to these things to show how they have to relate in a particular order or way. Regardless, each of these are designed, or they help you facilitate encoding and retrieval by chunking information and showing how things are related. So you can look at these organizers as in this network model, and they're kind of talked about it already, right? So they're fairly effective at fostering spatial summation by connecting images to words and how you use them or how you design them. What you really need to consider now, though, is how exactly you plan on going and making organizers. What type of organizer should you be, or should it be, for each bit of content? Where do you get the content for the organizers? How do you know it's right? Right? So these are all important questions to think about as you move through this course. Now, is there any guess as to where you can find the answers to some of those questions? Right? Remember, those questions are: what kind of organizer should it be? Where do you get the content for those organizers? How do you know it's correct? Now, if you said the answers can be found in the BIOS form, you'd be right. Excellent. Now, of course, there are some other resources to help you create organizers that I talked about in the Learning Resources video. One of which was the P's of Biology, which help provide a decent framework or structure for you to use when you create an organizer. Now, it doesn't always apply, but it works pretty well for a lot of the content. And at the very least, it often provides a good place to start organizing your thoughts and the vocabulary associated with that topic. P.E.P.P.E.R, the P.E.P.P.E.R worksheet, is also specifically designed to help you create and practice your organizers for each lecture. So you have this first section about organizing your notes, preparing your organizer. You have this second section here called validating your organizer, or validate the organizer, and it's about talking to your peers about the organizer, maybe in a workshop, and making sure it's correct. After all, you don't want to practice incorrect information. So this process of validating this organizer is a very active process. You want to be talking with people, you want to be drawing it, you want to be redrawing it, you want to be referring to your notes, going back and forth. All of that's very important and very effective learning. Okay? Now, finally, the practice organizer selection is where the P.E.P.P.E.R worksheet really shines. It's all about fostering that temporal summation, right? So practicing the organizer over and over and over and over and over and over to try to get as much down from memory as possible before checking it against your notes, right? The idea is that the more that you can recall without looking at your notes, the more prepared you are. The ultimate goal here is to recall the organizer perfectly several times without checking your notes. Now, if you can't recall it perfectly, it sounds like you probably need to practice it a little more. Once you can check all those boxes, though, you can really kind of move on to the next outcome in organizer, because remember, every organizer is equal to 1 or even 2 exam questions on the exam. The more organized you can recall, the more exam questions you can answer. But why do we want to do this without checking our notes, right? Why does it say recalled without notes? What does that have to do with? What does that have to do with learning? Do you have any guesses? Well, it actually relates back to memory, learning, and long-term potentiation. By trying to do it off the top of your head, you're forcing yourself to recall or retrieve that information from your long-term memory right? Which is one of the critical steps in the long-term potentiation process. And each time you actively work with the organizer by writing it down or talking about it, you're encoding that information. Okay, so that was the P.E.P.P.E.R sheet, and P.E.P.P.E.R should probably always be accompanied by S.A.L.T. Right, now with S.A.L.T, it's actually really kind of always worth adding some S.A.L.T to your studying routine. But why? What does that have to do with learning? Well, it'll be a little more efficient to talk about S.A.L.T in the context of some of the other resources. So you have S.A.L.T review sessions with me, practice sessions or practice groups rather with the undergraduates that you can sign up for later in the semester. These are all based on actively working with the materials, mostly by making and checking organizers and discussing with peers, as well as different ways to test yourself and each other by creating organizers or even practice exams. Okay, so what do the kind of the network models look like for each of these activities? What do we think? Looks kind of like this. Now, does that look familiar at all? Right. It's workshop. The only difference between these four things is that workshop is led by a graduate student facilitator, while in the practice sessions or practice groups, it's an undergraduate facilitator, and in the review sessions, it's run by either myself or Dr. Beal. Now, and of course, in the S.A.L.T activity here, it's actually you guys are running the show. Now, remember that phrase, workshop outside of workshop? This is why I've been saying over and over and over again, workshop outside of workshop. The process that we outline in the workshop and the S.A.L.T exercise is easily the most efficient way to practice the material by fostering spatial summation, right? All these different diverse connections to the material. And by doing it over and over and over again in both workshop, S.A.L.T sessions, review sessions, and practice groups, that's going to result in temporal summation, meaning you'll have both spatial summation and temporal summation, causing some serious long-term potentiation and memory formation. Awesome. Okay. So that's pretty much the content for today. I do want to go over two more things. The first of which is a little kind of intro to how we write questions or the types of questions we write, and then is an actual lecture question itself. Okay, now in general biology, we write questions based on this, what is called the solo taxonomy, where it looks at how information is related to each other. So you can have a question designed on these kind of different hierarchical levels of complexity or how things are, content is related to each other. So a kind of first level question will be asking you to identify or define or maybe do some kind of simple procedure. So that would be like, what is a prokaryote? That would be a pretty simple thing, right? Now, if you're asked to define, describe, or list, or maybe do an algorithm, that would be a kind of multi-structural approach to information, right? So you're asking to relate multiple things. So define a prokaryote, define a eukaryote. So these, you can be almost consider these first two levels as component level questions, while they're asking you to understand components of systems. While the upper level here, these level 3 to level 4 questions, these are kind of system level questions that you need to understand how things relate to each other. For example, you need to be able to understand how, you need to be able to compare and contrast how prokaryotes and eukaryotes are similar or different. To be able to do this, you need to be able to understand what prokaryotes and what eukaryotes are, right? That's important. So you're going to need to be able to understand this kind of component level content, as well as how to relate that component level content to each other. Finally, we're going to have you, there are these kind of level 4, where you're actually relating very kind of different types of information to each other. So that would be like saying, how did prokaryotes and eukaryotes evolve through the process of abiogenesis? You probably don't know what half those words mean. That's okay. We'll get to that. You should be able to answer that question eventually. But you're asked to come up with broad ideas, relate broad concepts to each other by evaluating how they're related, coming up with a theory, generalizing, predicting, creating, hypothesizing. We like to use hypothesize a lot here in general biology. Now, when we write exam questions, we try to write them geared more towards the level 3 or level 4 type question. And in fact, we specifically design the exam so that at least 50% of the exam is going to be level 3 or level 4. Now, why? Are we deliberately making questions harder? Is that what we're doing here? Not necessarily. We're doing it this way because most of the graduate level kind of general exams that you're going to take, be it the MCATs or the GREs, their questions are all of this kind of nature. Level 3s or level 4s, where they're asking you to hypothesize or diagnose or compare and contrast, that kind of thing. So that's why we are structuring the course and the exam questions the way we are. So that's also why we give you the outcomes that we do. We'll ask you to compare and contrast a lot of this stuff, right? So anyway, I just want to give you some kind of like look behind the curtain, so to speak, of what this looks like and how it functions, why we design the exam questions the way we do, and what this means in terms of how the information is organized. That's all. So a little bit of a long rambling thing. I think Dr. Beal might even be doing a little video that covers this more explicitly, but I wanted to just talk about it here because it'll help you answer some practice questions like lecture question 1.2. Now, here's a good one. Doing workshop outside of workshop many times fosters learning because of 1, spatial summation, 2, long-term potentiation, 3, temporal summation, or 4, passive learning. So it's up to you to identify which combination of these options are correct and then select the correct answer below. In the beginning of lecture 2.1, I'll actually talk about the different options and why some were correct versus others. But like I said, that won't always be the case, so try to come up with the answer ahead of time and have a good understanding of why that's the answer. Okay. Oh, I should do this. Finish filling out the bios form here. Forgot to do that. There we go. Cool. Okay. Now, in lecture 2.1, we're going to be talking about themes in biology, as well as methods of investigating biology. So, I'll see you next lecture. Well, I actually won't see you because this is all recorded. I'll see you in the review sessions, which you should attend. So there's that. Okay, bye.